Welcome back everyone. In today's video, I'll be explaining AtCoder Beginner Contest 320. I'll explain the problems from C to F. I've provided the correct Python codes in the video description, so please check it out after you've listened to my explanation. Let's get started with problem C. There is a slot machine with 3 reels. We want to stop all the reels so that all the displayed numbers are the same, but we can't stop reels at the same time. Our target is to find the minimum time to align the numbers. At first thought, you notice that the reels are just 3 and the size of the hand arrangement of each reel is also small, that is 100. So we solve the problem with brute force algorithm. We try every order of pushing buttons and every number to display, and then consider the fastest way to display the fixed number with a fixed order. After fixing the order and the number, our algorithm is like this. Here we assume that we push the buttons as S2, S3, and S1, and align number 4. We start with t equals 0. Let a variable dt move from 0 to m, and we check the numbers of S2 with the index t plus dt mod m in ascending order of dt. When the number comes to be 4, this means that we should stop the reel after time dt. So we add the dt value to t and then go to the S3 reel. We repeat this operation 3 times, and the result time t is the fastest time to stop all the reels with the fixed order and the fixed number. Therefore, the answer to the problem is a minimum for all these candidates. This finishes the explanation of problem C. Let's proceed to problem D. We have n points on xy plane. The first point is the origin, and we are given m pieces of information of a difference between 2 points. Our target is to find the coordinates of all the points. Let's get started. Firstly, we regard this problem as a graph coding problem. With given information of a difference, we can construct a directed graph with n vertices and m edges. But the graph is still not convenient. You notice that for each directed edge, you know the inverse edges are as the right figure. For example, if a difference from one point to another is +2 for x-axis and +1 for y-axis, then the difference from the latter point to the former point is -2 for x-axis and -1 for y-axis. So we add n more edges to the graph, and the graph comes to be like undirected one. After complementing edges, we can determine points from closer points to the origin, like this figure. We'll achieve this with BFS algorithm. Leave the details of the algorithm to you. This ends the explanation of problem D. Now, let's proceed to problem E. We have n people and q events. For each event, a person eats a quantity of noodles, and after that, he leaves the receiving row for a certain time. Our target is to find the sum of the quantity of noodles each person will eat after all the events are finished. Our first job is to consider what information we should record and what operation is needed for the information. First, we need to record the information about who is in the row at a certain time. And as operations, we need to switch each person's existence quickly and find the minimum index among the present people. To satisfy all the requirements, we should prepare a segment tree. Second, since people come back after eating noodles, we need to stock these comeback events and take them out one by one in need. So we require a list with inserting elements and popping elements out in ascending order of time t. Therefore, we use a priority queue. Now we solve the problem with these two data structures. Let variable seg be a segment tree to record the information about who is in the row, and queue be a priority queue to record comeback events. At the beginning, the ith value of seg is I, which means that person I is in the row, and queue is empty. When an event begins, we take the ranged minimum of seg from 0 to n, and we can find the minimum index and know who eats noodles. Then the person is out from the row. The value of seg should be infinity, and append to queue the information about when he comes back to the row. Then, before beginning the next event, we check elements in queue in ascending order of time and change the value of seg from infinity to the index number. The series of operations simulate the events very well. So we can calculate the answer. We complete the explanation of problem E. Finally, let's proceed to problem F. We do a round trip starting with the origin. For each I, there is a gas station at xi, but we can use each gas station only once during the round trip. Our target is to find the minimum expense to achieve the trip. Let's get started. We solve it with dp because it's a kind of snapshot problem. The most important idea in the problem is to think about both the way to go and the way to return at the same time, not respectively. So we define dp of I and j and k as the minimum expense to reach xi with j fuel to go and k fuel to return. From this state, we decide how to use station I and think about the transitions to the next state dp of I plus 1, jn and kn. Now assume we are in the state dp of I, j and k and think about the case where we decide not to use station I. In the left figure, the black line represents the way to go and the red line represents the way to return. Let d be the difference. Considering the next state, the fuel to go must decrease by d, and the fuel to return must increase by d. So the next state can be represented as follows. This case is done. Next, we think about where we decide to use station I for the way to go. The way to return is the same as before, but the fuel to go increases by station fuel F and then decreases by D. We should be careful about the limit of carrying fuel H, but this case also be done. The third case is to use station I for the way to return. The outline is the same as before. The fuel to return decreases by F at first and increases by D. So we should not forget to check K minus F is greater than or equals to 0. Then this case seems to be done. However, this is good only where K not equals H. Here, we must think carefully about the difference between the case of K equals H and K is not equals to H. Consider the case of K equals H and add fuel at station I for the way to return. When exceeding H after adding fuel, the total result carrying fuel is just H. Therefore, the fuel Kn, which is the fuel at xi plus 1 to return, is not unique. So for this reason, we let kk be a new variable representing the fuel before k, which means the fuel before supplied at station I. Kk ranges from h minus f to h, and Kn is represented as Kk plus D. So we can write down the transition in this case. These are all the possibilities and we've finished constructing DP. With that, I've completed all the explanations. If you have any questions about the problem or any requests for solving other ABC problems, please feel free to comment. Thank you for watching the video.